In this video, we're going to learn about acceleration. We're going to learn about what it means, what is acceleration, and we're also going to learn how to use the main acceleration equation, which is acceleration is change in velocity divided by time. Please answer these 5 questions, pause the video, and once you're done, play. Okay, please mark those 5 introductory questions using the answers here. Pause the video while you do that, and then press play once you're done. So these are all things that you need to know already in order to understand acceleration. It's especially important that you know that the units of velocity are meters per second. The slash means per. And it's very important that you know how to convert minutes into seconds, because seconds are the official unit of time in physics. And any equation which has time in it, you have to use the time in seconds. So we're going to start by finding out what acceleration is. I'd like you to think, what does acceleration mean? Write it down in your exercise book. So pause the video and write down what you think acceleration means. You've probably written down something like acceleration means speeding up. Sometimes people also think about cars and they think about force. So all of those things are related to acceleration, but they're not the official definition of acceleration in physics. In physics, the official definition of acceleration is the rate of change of velocity. Now, there are 2 key words there that I want to understand. The first is the word rate, and the second is the word velocity. Word rate means how fast is that happening. It means per second. And velocity is what type of quantity? Say your answer to the video now. Velocity is a vector quantity, so it's a speed with a direction. The fact that velocity has a direction is very important. So acceleration means how fast is your velocity changing? Now, to have a changing velocity, your velocity needs to be changing. Now, that doesn't just mean speeding up. A change in velocity is any change of velocity at all. So that can mean speeding up, which is the obvious one, but it can also mean, say to the camera what you think. It can also mean slowing down. I'm not using the equal sign very well here. I'm going to use an arrow instead, because an equal sign is a mathematical thing, and this is not maths, this is just a definition. So change of velocity can mean speeding up or slowing down. But finally, velocity is a vector quantity, which means it has a direction. So if you change your direction, you are changing your velocity. So a change of velocity can also be changing direction. So that means if you speed up, or if you slow down, or if you change direction by turning a corner or going round a roundabout, for example, you are accelerating. So acceleration in physics doesn't just mean speeding up. It means speeding up or slowing down or changing direction. Now, this here is the equation for acceleration. We're going to be using that equation, but before we can do that, we need to make sure we know the units for each of these quantities. So please say to the video now what you think the units for change in velocity is. Hopefully you've said that the units for change in velocity is meters per second, because the unit for velocity is meters per second. Say to the video now what you think the units for time are in physics. The unit for time in physics is seconds, always seconds. So the new quantity that we're learning about here is acceleration. So I'm going to tell you the units for acceleration. So the unit for acceleration is meters per second squared. Meters per second squared. Now it's much easier to just write that like this, m/s squared, meters per second squared. Now, why is that the unit? Well, if we think about it, if acceleration is the change in velocity divided by time, that means acceleration is how much does your velocity change each second? How much does your meters per second change every second? So it's your change in meters per second. So it's your change in meters per second. That is meters per second squared. Now you don't need to know that explanation, but you do need to know that the units for acceleration are meters per second squared. Now we're going to practice using this equation. We're going to find out all sorts of things. We're going to work out acceleration, we're going to work out velocity, we're going to work out time. The first thing we need to do is understand this symbol over here. This symbol over here is a triangle. It's a Greek letter and it's called delta. And what delta means in physics is change. So when I write A equals delta V divided by T, that means acceleration is change in velocity divided by time. So we're going to start by looking at change in velocity. Please pause the video and read this question. So the question wants to know, what is the change in velocity? So we're not yet working out acceleration, we're just working out a change in velocity. So the way to work out a change in velocity is like this. So a change in velocity is your final velocity minus your initial velocity. What does the word initial mean? Say your answer to the video. Hopefully you've said that initial means your starting velocity. So to work out your change in velocity, you do your final velocity minus your initial velocity. So in this question, it's accelerating from rest to a speed of 10 meters per second. So the final velocity is 10, and the starting velocity from rest, so that's 0. Therefore, the change in velocity is 10, don't forget units, meters per second. So the change in velocity is the final velocity minus the initial velocity, 10 minus 0, which is 10 meters per second. I'm going to do another example. Please read this question. So we're going to do it in the same way, but you're going to help me this time. So how do we find a change in velocity? Say your answer to the video. Hopefully you've said that to find a change in velocity, we do the final velocity minus the initial velocity. What's the final velocity in this question? You should have said 9.5. What's the initial velocity in this question? You should have said 4. Therefore, the change in velocity is 5.5. What are the units for velocity? You should have said meters per second. So in this question, the change in velocity is 5.5 meters per second. Let's do one more example. So read the question to yourself. So how do we find a change in velocity? You should have said it's the final velocity minus the initial velocity. What's the final velocity here? The final velocity here is 1.8. What's the initial velocity here? The initial velocity here is 2.2. So we're actually minusing a bigger number from the smaller number. So that actually gives us minus 0.4. What are the units for velocity? Yeah, meters per second. And that means it's slowing down. So this minus over here tells us that the bicycle is slowing down. So don't worry if you get a negative answer, just means that you're slowing down. Now that we know that, we can now use the equation to find acceleration. Read the question to yourself. Okay, so to do equation questions, we're going to use the method of discus. Hopefully you've used it before. D means data, E means equation, S means substitution, C means calculation, U means units, and S means significant figures. If you want to go over that, rewind in the video, watch it again, and make a note in your exercise book of what each of those letters stands for. So in the D section, data, we're going to write down what we know, and we're also going to change any units to the physics units if we have to. So I read the question and I write down what I know. Calculate the acceleration when a car accelerates from rest to 8.6 meters per second. So that means my change in velocity is going to be 8.6 minus 0, which is 8.6. That's something we just did. Over a period of 1 minute. So that means my time is 1 minute. I have to change that into seconds because this is physics. So it's 60 seconds. Next, we write down the equation. So acceleration is change in velocity over time. The change in velocity is 8.6. The time is 60. You're always allowed to use a calculator in physics. So I type that into my calculator and I get an answer of 0.143. Now you might be wondering, what are all these other sections? S, well, S is substitution. So what I did over here, I should have actually done on the next line where it says S. So that should be S. And then the actual calculation, which you can always do on a calculator, should be where C is. So D is the data, so you write down the data. E is the equation, you write down the equation. S is the substitution, where you replace each of the letters with the number. C is the calculation. U stands for units, so I need to remember to write down the units. So I'm finding acceleration. What are the units for acceleration? Hopefully you remember it's meters per second squared. Finally, S stands for significant figures. So in the question, I've been asked to write my answer to 2 significant figures. At the moment, I've written my answer to 3 significant figures, so I need to round it to 2 significant figures. So my final answer is 0.14 meters per second squared. We're going to do another example together now. Now I'm going to do this example fully by myself, just so you can see the whole Descus method being done in one go. So I'm going to do it quite quickly, but very, very clearly. D stands for data. I write down what I know. So my change in velocity is my final velocity minus my initial velocity, which in this case is minus 0.5 meters per second. In this question, the time is 4 seconds. I then write down my equation, E for equation. So acceleration is change in velocity over time. The next letter is S for substitution. So I replace each letter with the numbers that I know. So I don't yet know the acceleration. The change in velocity is negative 0.5. The time is 4. I then actually use my calculator, because you can always use a calculator in physics to do the calculation. So the answer is minus 0.125. U stands for units, so I need to remember the units for acceleration on meters per second squared. And finally, I need to check the number of significant figures. In the question, I've been asked for 3 significant figures, and my answer is already to 3 significant figures. If you're worried about this negative sign, don't be. It just means it's slowing down. I'd like you to now try this question yourself in your exercise book. Pause the video and press play once you're done. Hopefully, you followed the method step by step using Descus. So the first thing I'm going to do is write down Descus so I don't go wrong. D for data. So my change in velocity is going to be 29.75 minus 19.25, which is 10.5. My time is 2.5 minutes. You should have changed that to seconds by timesing it by 60. 2.5 times 60 is 150 seconds. E for equation. Acceleration is change in velocity over time. S for substitution. Acceleration is 10.5 over 150. C for calculation. I can always use a calculator. I get 0.07. U for units, the units of acceleration are meters per second squared. S for significant figures, nothing's been specified in the question, so I'm just going to leave my answer how it is. Please mark and correct your answer. Pause the video while you do that, and then press play once you're ready. Okay, moving on. So we've used the equation to find acceleration. The next thing we're going to do is use the equation to find a change in velocity. So we follow Discus in the same way that we always have. So the first thing we do is D. What does D stand for? Hopefully you've said data. So what is the data that we know in the question? Say your answer to the video. So we know that the acceleration is 2.8 meters per second squared. If you weren't sure whether that was a velocity or an acceleration, just check the units. Meters per second squared, so it must be an acceleration. The other thing we've been given is the time. Do that in blue. Time, which is 8 seconds. What does the E stand for? Equation. What is the equation for acceleration? Acceleration is change in velocity over time. What does the S stand for? Substitution. So we fill in the numbers. A is 2.8. Change in velocity we don't know. And the time is 8. The C stands for calculation. So I've got 2.8 equals change in velocity divided by 8. So that means 2.8 multiplied by 8 is going to be my change in velocity. Rearranging equations is an important part of maths. And when I work that out on my calculator, I get 22.4. Here I found a change in velocity, so the units are meters per second. So just to summarize, I wrote down the data, I wrote down the equation, I substituted my numbers in, and left change in velocity as just delta V, because I don't know what that is yet. I then rearranged the equation to solve to get my answer, 22.4 meters per second. Please read this question, pause the video while you read it, and then press play. So we're going to do this one together. So what should I write down first? Say your answer to the video. Hopefully you've said that I should write down Discus, D-E-S-C-U-S. Next, we're going to do D. What does D stand for? Data. Say what you think the data that we've been given is to the video. The data we've been given is the acceleration, which is actually negative 0.7. Why do you think it's negative? It's negative because it's decelerating. What else have we been given in this question? We've also been given the time, and the time is 0.8 minutes. Is that the correct unit for time in physics? Say yes or no to your video. The answer is no. So what are the correct units for time? You should have said seconds. And how do we go from minutes to seconds? We times by 60. So 48 seconds. You can use a calculator always. What does the E stand for? Equation. And what is the equation for acceleration? You should have said acceleration is change in velocity over time. Let's do S now. What's S stand for? Substitution. So my acceleration is negative 0.7. Change in velocity, I leave how it is. And what's the time here? Time is 48 seconds. Now we do the calculation. So how am I going to work out the change in velocity if minus 0.7 equals change in velocity divided by 48? Say your answer to the camera now. So we're going to have to do negative 0.7 multiplied by 48. You can always use a calculator. That gives minus 33.6. Next is U. What does U stand for? It is units. And what are the units for change in velocity? The units for change in velocity are, hopefully you've said, meters per second. Finally, what does the S stand for at the end? The S stands for significant figures. In this question, we've not been asked for a specific number of significant figures, so we'll just leave the answer the way it is. If you found that a bit trickier than some of the previous examples, feel free to just rewind and watch it again. So far we found acceleration and we found change in velocity. So the next thing we're going to do is find time. So I'm going to do this example fully myself. Please pause the video and read the question. So I'm going to do this question fully myself so you can see the flow. So D stands for data, so I'm going to write down my data. It accelerates from rest to 8.2, so that means the change in velocity is 8.2 meters per second. And I'm told the acceleration is 0.6, so acceleration is 0.6. So I'm writing down what I know. Next, I have to do E, which is equation. The equation is acceleration is change in velocity over time. My change in velocity here is 8.2, and the time is 0.6. That's my substitution. I can do that on my calculator to do my calculation. So C calculation will be 13.6 recurring. So let's just write a few decimal places. U stands for units. So this was a time. Aha, I have just made a really easy mistake to make. The fact that I've made it tells you how easy it is to do. What I did is I quickly started substituting. But when I substituted, see if you can spot my mistake and say your answer to the camera. So my mistake is that I put my time as 0.6. Now that's wrong. So what I'm going to do is delete what I've done and go back to substitution, but carefully this time. So I've got the equation, acceleration is change in velocity over time. I'm now going to substitute carefully, not in a rush like I was doing before. So A is acceleration. I've got in my data that acceleration is 0.6 equals. My change in velocity is 8.2 and my time I don't know. Now, before I can do the calculation, I need to rearrange this. So to rearrange this, I'm going to multiply both sides by t to get 0.6t equals 8.2. And then I'm going to divide both sides by 0.6 to get t 8.2 divided by 0.6. Now, this happens to be the same answer, but that's just a fluke. I have to do it properly. U stands for units. The units for time are seconds. And then significant figures. The question says give your answer to one decimal place. So I'm going to round this to one decimal place, 13.7 seconds. If you want to watch how I did that, rewind the video and watch it again. Now we're going to do an example together. So pause the video and read the question. So what should we do first? Say your answer to the video. Hopefully you've said that we should write down discus. What does D stand for? Data. What's the data that we know in this question? Say your answer to the video. So we're told that the acceleration is 2. And we're also told the starting speed and the final speed. So looking at that starting speed and final speed, what do you think the change in velocity is? So if we're speeding up from 1 to 9, that means the change in velocity must be 9 minus 1, which is 8 meters per second. Now that I have my data, I can do the rest of the question. What does E stand for? Equation. And what is the equation for acceleration? You should have said acceleration is change in velocity over time. What's the change in velocity here? Let's do the substitution now. Well, to do the substitution, we need to go to the next line and do it very carefully. So do we know A? Yes or no? Yes, we do. And what is A? A is 2 equals. Do we know the change in velocity? Yes, we do. And what is the change in velocity? The change in velocity is 8. Do we know the time? No, we don't. That's what we're trying to work out. So what should I write underneath the 8 here? I should write the letter T. Next, we have C. What does C stand for? Calculation. So we need to rearrange the formula. So pause the video and find out what T is equal to. Hopefully, you've rearranged correctly. So you should have done multiplying by T to get 2T equals 8, and then dividing by 2 to get T is 8 divided by 2. You can always use a calculator, although 8 divided by 2, you shouldn't need one. 8 divided by 2 is 4. What does U stand for? Units. And what are the units of time? Seconds. Finally, what does the last S stand for in Descus? It stands for significant figures, but in this question, we've not been asked for significant figures, so we just leave our answer as it is. Again, if you want to look through that question again, just rewind the video and watch it again. Finally, this is the hardest kind of question you can get with this equation. So we're going to find the initial or final velocity, but we're not going to worry about that until the end of the question. So we're going to do normal Descus first. So pause the video to read the question and then press play. Okay, so we're going to write down what we know. So we know that an object accelerates at 5.6 meters per second squared. So that's the acceleration, 5.6 meters per second squared. I'm told it does that for 3 seconds. 3 seconds, seconds tells me that's time. So my time is 3 seconds. I'm also told the initial velocity, but I'm not going to worry about that. I'm just going to use the equation to work out the change in velocity. So E stands for equation. Acceleration is change in velocity over time. S stands for substitution. A is 5.6. Delta V, the change in velocity, I don't know. And T time is 3. I'm going to rearrange to get 5.6 multiplied by 3 is delta V. So therefore, my change in velocity, I can always use a calculator. It's 5.6 times 3, which is 16.8. U stands for units, so that's meters per second. Now, that's my change in velocity. I'm told in the question that my initial velocity is 8.2. So if my initial velocity was 8.2, and I've now changed my velocity by 16.8, that means my final velocity is going to be 8.2 plus that change. So 8.2 plus 16.8. And that's going to be 25 meters per second. I can quickly check that makes sense by just looking back at the question and asking myself, was I speeding up or slowing down? So it says an object accelerates, not decelerates, it says it accelerates at 5.6 meters per second squared for 3 seconds. So I should be at a faster speed. So just to summarize what I did, I used Descus to find the change in velocity, and then I added that change in velocity to my initial velocity to find the final velocity. That's the hardest it can get with this equation. So if you found that difficult, I'd recommend that you watch it again before we do another one together. So here is another example that we're going to do together. So pause the video to read the question and then press play. What should we do first? Hopefully you've said that we should write down Descus. Okay. I want you to take a moment to decide what we can write down for D. Pause the video while you think about that, and when you're ready with an answer, press play. So hopefully you've said that we should write down acceleration is 0.05 meters per second squared, and also that the time is 1.2 minutes. Did you remember what to do with those minutes? How'd you go from minutes to seconds? Hopefully you said you times by 60, so that's 72 seconds. Now, hopefully you've also just ignored this final velocity for now. That would be a good thing to do. Just ignore that for now. We're just going to use the equation to find the change in velocity first. So E stands for equation. What's the equation for acceleration? So hopefully you've said acceleration is change in velocity over time. Let's do the substitution now. So what is A for this question? 0.05. What is delta V for this question? Hopefully you've said that we don't know it, so we just leave it as delta V. What's T for this question? T for this question is 72. Now we need to rearrange it to find delta V. Pause the video to do that and press play once you're ready. So you should have rearranged as follows. 0.05 times 72 equals delta V. Therefore, delta V is 3.6. U is units. So what are the units for velocity? Say your answer to the video. You should have said meters per second. Now we've worked out the change in velocity, but we need to work out the initial velocity. So in the question, we're told it reaches a velocity of 9.4. If it reaches a velocity of 9.4, do you think that 9.4 is the initial velocity or the final velocity? Say your answer to the video now. The correct answer is that 9.4 is the final velocity. So if 9.4 is the final velocity, we need to minus off that 3.6 to find out what the initial velocity is. So we do 9.4 minus 3.6, and that is 5.8 meters per second. So notice that its initial velocity is slower than its final velocity because it was speeding up. So just to compare those two questions before we move on, in this question, you were given the initial velocity and you had to find the final velocity. So you had to add the change in velocity to the initial velocity, which we did over here. And in this question, you were given the final velocity and you had to find the initial velocity. So we did the final velocity minus the change in velocity, which we did here. Now, here are a load of questions for you to do, but don't start them yet. If you do these questions, and if at any point you are stuck, please feel free to rewind the video and find the relevant section. I would recommend that you always try the question first before going back earlier in the video to help. So always try it first. Don't look ahead in the video. Try all of these questions, all 14 questions, do them in your exercise book. Look back in the video whenever you need, but always try the question first. So let's say you were doing question 9 and you were stuck. Try it first, then look back in the video to see if you can find something to help you. Once you've done all 14 questions, then press play again. So I'd like to pause the video now, do these 14 questions in your exercise book, and press play once you have an answer to every single question. If you've pressed play and you've not done every single one of those questions and tried every single one, your learning is not going to be as effective. So if you've not yet done every single question, pause the video again and do every single one of those 14 questions. You could even have a break, do them later, but do not move on in the video until you've done every single one of those questions. Okay, now I'm hoping that you've done all 14 questions. So here are the answers to questions 1 to 9. Please pause the video to mark those questions. And finally, here are the answers to questions 10 to 14. Please pause the video to mark those questions. Hopefully your understanding of acceleration now is much better than it was before. Remember, the crucial thing is that acceleration is not just speeding up in physics, it's any change of velocity at all. Any change of velocity, speeding up, slowing down, or changing direction is an acceleration. And we've also spent quite a bit of time learning how to use the acceleration formula to find out all sorts of different things. Please like this video and subscribe so that you get notifications about any more GCSE videos which I post.